Today we are here in Fujairah together with my colleague Mr. Vineeth, our solution engineer for Geospatial, and today we have the objective to getting the ground points for his case study. So let's get into it.
So this is the area we are surveying for the 2D topographical survey as well as 3D modeling of this land. They need 3D model for the road corridor and infrastructure works, which they will initially work on their CAD software, Civil 3D, and later render it on Unity 3D. So my case study is regarding land survey. So we have done already the surveying and now we are doing the reverse marking of the GCP. So we will be using two DRTK3, one as base, one as rover, to getting the ground control points, which is studied from the map.
So how's it going right now?
So now we have initially set up the base station. Now this point you can see it's a non-point which we surveyed, and we have set the base station there. So we're using this base station as a reference. Now we'll be connecting to the rover, and we'll be using this base station with the reference to this rover, and we'll take in the ground control points. So once we have set the rover mode enabled, so we'll go to the DJI Enterprise app and we'll create the task, and we'll be enabling, we'll be setting a new point name, and after that we'll be setting the tilt mode. And for tilt mode we'll have to calibrate. We'll add the point and the point will start converging and we'll confirm the task. So this is the second point and we'll be adding the task here. So we'll continue with the same procedure we did for the first time. We will just add the point and we'll start converging and the task will be created.
Yeah, so Vineeth, how is it going so far?
It's going good so far. We have collected 2 points. Now we are moving on to the third point. So this lab edge is the third point which we are doing, and we have done the point. So we have recorded the ground control point on the DJI Enterprise app. Now let's move on to the fourth point. And we move on to the fourth point as well as the fifth point. The points collected should be stable ground points. So with few hurdles, we got the landowner's permission and we collected all the points.
How's it been, bro?
All good. And we'll be using it as a checkpoint as to verify the accuracy. If the accuracy is not matched, we'll be using ground control points to correct the checkpoint.
Yeah, got it. Hey guys, Mark here. So behind me is Vineeth finishing up the work. We are at our last point and I hope we got all the points that we need for the case study. So let's see. We have just finished getting all the ground points, and Vineeth, how was it?
It was well. It went well.
It went well?
Yeah. We got 6 points. And now we'll get back to the processing part for reverse marking of GCP. Yeah.
So where will we process it?
We'll be processing DJI Terra.
Okay, so we'll be using DJI Terra to process it, and we will show you later on this video.
Once the points are collected, we head back to the office. For the post-processing part, we specifically choose DJI Terra for the DJI product being easily manageable across DJI ecosystem and its easiness to use. So we start by importing the acquired points into Excel and saving into CSV format and marking the points one by one. Out of the 6 points we collected, we used 2 as checkpoints and 4 as ground control points. We were able to achieve less than 3.5 cm horizontal accuracy and 2 cm vertical accuracy, which qualifies as survey grade accuracy. For visualization and analysis of the post-processed 3D model, we are utilizing DJI Reality, the platform for the model review, inspection and client presentation. This enables accurate assessment of the site's existing terrain condition and spatial dynamics. We will provide more detail and overview of the DJI Reality and its workflow capabilities in our coming videos. As demonstrated here, the client is utilizing the processed terrain model for integration with their CAD model. The generated survey and mapping data served as the foundational reference for the engineering workflow. The CAD model was developed using Civil 3D and subsequently rendered within the Unity 3D for advanced visualization and simulation purposes. Here you can observe a side-by-side comparison of the wireframe model and the fully integrated 3D model. This comparison provides a clearer understanding of the model structure, terrain integration and its practical application within the client's construction and planning workflow.
And that concludes this case study at Aerosmart. We used DJI Matrix 4E with dual DRT-K3 to achieve high precision mapping in the field. If you want to learn more, just contact us at sales@aerosmart.ae. See you in the next video.